Hi everyone. So we'll start off, and as usual, we'll have the same format. We'll start off with a story. Yeah. So for the first time, as I said, with arithmetic or with QA in general, I was when didn't come naturally to me. I was good at DILR. I was good at verbal, but somehow the flair that I had in both of those sections never got translated into my QA performance, and I was very clunky, or say, I don't know, I didn't have the same confidence. I didn't have the same speed to solve. So I clearly remember the first time things changed for me was during my during a mock feedback. So my mentor back in the day, many years ago. So I still remember I was sitting around 10 rows behind. He was doing a mock feedback. So all the batches were clubbed together. And what he said, what he did, what he was doing with those time speed distance problems, because that back in the day quant was an entire section of say 55 questions, and there was enough and more arithmetic as well. So he would stand like this, and then he would say, the board was way behind. It was almost as if he's not going to use the board, and he would stand and then he would constantly solve, like, okay, more men, less time, high, speed is going up, time will come down. So he used to do this thumbs up, thumbs down, and he was just solving those problems as if they were nothing. And he would go to the board just back to write a few numbers, and I was sitting there and watching, and I'm like, okay. And I was the usual, like most of you people, maybe, I don't know, not most of, I shouldn't generalize, but I was the S into T is equal to D sort of a guy. I needed to strike that equation. Right? And I was sitting there and looking at him go through these problems in absolutely such a smooth manner. That is when things changed for me in my head. I'm like, okay, and my first reaction was, I want to do that. And after that, since that session till now, I have not written S into T is equal to D, or that is not my first approach, right, to solve a problem. Because once I saw that, I thought that there was no point in me going back and trying to do my old-fashioned method. So the thing with math is, so those of you who are in the friend zone, especially those of you who feel you have some capability, but it's not going anywhere, a lot of it is maybe because you haven't been showed the way. Some people understand this intuitively and do it. For others, somebody just needs to show them the direction, and hope in this session today we'll do that direction bit. I can show you the direction after which you can go ahead and do that. Yeah. So that was the first time for me, a very key point or key change during my preparation. The moral of this particular story is that always adopt the faster method. It does not matter whether you can solve the problem or not. So it was not that when I was using S into T is equal to D, I was not getting the answers, I was not solving. No, arithmetic was my strongest suit within the quant, right? Because if you're good at reading comprehension, you can process English at a particular pace. That also translates, and verbal reasoning, obviously. It's not just being good at reading comprehension. If you're good at verbal reasoning, it translates fairly well in most cases into an arithmetic situation as well. So that part was there, but it's not about whether you can solve it or not. Most students, I feel, are happy if they can solve it. And they're only this thing, I don't know how to solve it, can somebody. Think about it. Even in the future, when you become MBAs, you have a product that does the job. Somebody else has a product that does the job better. Customers just feel much better using that product. It seems more elegant. It's more smoother, right? Would you stick to the fact that my product is good enough, it does the job? No. Doing the job and getting the answer, it's good enough, just doesn't work, both in CAT as well as in terms of what in our work life in the future, right? Because is your product, is your method, what you're doing, is it the best that is there out there? Right? So this is a mindset that I want you to adopt, that during arithmetic or during anything, just don't be happy if you know to solve the problem. Another thing that I've heard, is often is that sometimes we come up with these methods that do not involve us faster. Students come back and say, sir, but what is the traditional method? Can you tell me the traditional method? But there is nothing called traditional or original, and as if this is a non-traditional modern new age method or whatever, right? Everything is just, the core still remains the same. We just change, what you call, it's just a different way of looking at things, right? So this is what I want you to keep in mind. A disclaimer. This, whatever we'll be discussing today, is one of the methods of solving. I'm not saying this is the only method or this is, this you have to. This is one of the ways of solving whatever your teachers have done so far, with, wherever you've been studying, with whoever you've been preparing. This session does not mean that whatever they've been teaching you is wrong or incorrect. No, all of that is valid, right? But maybe I feel that this is a faster method, a better method, because I also feel that if I did this right at the beginning, if say suppose you're exposed to this right at the beginning of your prep of say time, speed, distance, or even arithmetic, a lot of people will get scared, right? Because they're used to solving normally. They'll be like, okay, what's this guy saying? Why is he doing this? Right? So I feel that whatever your teachers have taught, that is a base so far. Right? And now let's see, can we go faster? Some parts will start off slow. We'll start off with a few basics. And as we go ahead, we'll increase the intensity on a few problems, right? And I'll ask, on some of the problems, I'll open a poll. On the others, I won't open a poll. On the chat, you guys can type in the answers. Yeah. Okay, so before we go anywhere else, the main thing what I like, why ratios are very, very important for me is that everything in arithmetic is a ratio, right? So percentage is a ratio, time is a ratio, speed is a ratio, rate is a ratio, interest is a ratio. That is why ratios, being very, very strong on ratios, it's something that applies across arithmetic. While because it's just a one session and we cannot cover the entire length, we'll be focusing on time, speed, distance, and time and work primarily. But otherwise, everything is a ratio. If you remember my previous weighted averages webinar, I said that the whole of arithmetic is divided into only three concepts, which is ratios, averages, and weighted averages, right? So we dealt with weighted averages then, which is why I wanted to deal with ratios now, at least the most important aspect of it. The next thing before we go ahead is that I wanted to stress on is, if you do not know this by now, you're not preparing for CAT. What do I mean? If you do not know this, ratios to percentages and vice versa. So by now you should know all of these things clearly, so that 1 by 2 is 50%, 1 by 3 is 33.33%, 1 by 8 is 12.5%, 1 by 11 is 9.09%. You should know all of this, right? By now, these things should be on your fingertips. And the second part also is very important. You should know the percentage and increase and decrease as ratios. Yeah, speed falls by 25%, that's 3 by 4. Something becomes, increased by 20%, that's 6 by 5. So all of these, right? All the ratios from 1 by 2 to 1 by 12, knowing those in percentages and being able to quickly convert increase and decrease into this, right? Because you cannot not know it. We've just finished SimCAT 7, so you cannot not know this stuff, right? So the advantage of this is in many ways, not just knowing the specific number or the fraction, but you also need to know the multiple of it. What do I mean by multiple? If a problem says that, okay, the speed is increased by 37.5%, you should know that 37.5% is nothing but 3 by 8. 1 by 8 is 12.5, 3 by 8 is 37.5, right? So that is the kind of stuff that you need to have. This is the core that you need to have. Once you have this, then we can build, right? This is that core fitness, core muscle, core stamina, everything that around which, say, arithmetic is built. So if you've not done this so far, ensure that all the ratios from 1 by 2 to 1 by 12, you know them as percentages as well. And if you see a percentage, you should know what the ratio is, and you can play with the multiples as well, right? Now, given that this is it, we'll start with the problem. First, all of you know this. I don't need to tell you, speed and time are inversely proportional. That means that the same distance you're going to office, you're coming back from work, same distance, you double your speed, you reach in half the time, you triple your speed, you reach in 1/3 the time, right? Your speed becomes 2/3. That means the time becomes 3 by 2, right? So speed 2/3, time 3 by 2, speed 1/3, time 3 times. This is the core from which we will be operating. And by now, I'm sure that you should be comfortable with this, right? So speed becomes more than twice, then time will become less than half, right? So that is what we're going to do. We'll start off with a very simple problem, not too difficult. This is the basic move. Do this and tell me the answer. You can type the answer out in the chat. Good. I think we're already seeing, but I'm seeing two answers. Some are saying 45, some are saying 60. I don't know how that is. Okay. I think most people have come up with the answer. No. So how do we go about this? So it's the most, that's why I'm calling it a basic move. It's a very standard, this thing, X drove to work 25% slower than a usual speed and thus reached office 15 minutes later than usual. How much time does a drive to work usually take? So it has to be a very simple thing. 25% lower means 75% of the speed. 75% of the speed means 3/4 of the speed. 3/4 of the speed means 4/3 of the time. So 4/3 of the time, how much is extra? How much is the numerator more by 1? So 4/3 of the time means the extra time is 1/3 of the usual time, right? 1/3 is extra, whatever is more in the numerator. 1/3 extra, that 1/3 extra is nothing but the 15 minutes late that she's reaching. So the total time is 45 minutes, right? But this is a very basic move. So this problem should have been done, say, in 15, 20 seconds without any pen on paper. So this is a core move that you should know, right? So this, based on this, now we'll see all the applications that we can, pull out based on this, right? So this part is clear. So this is how this works. Now, same thing, just so that, because the students at different levels have, kept the starting a bit slow. Look at this one. Getting some answers, getting different answers, 75, 90, 60, okay. 90, 72, okay, yeah. So the template is again the same, right? X drove to work 25% faster. 25% faster means what? 100 plus 25% is 125%. 125% is nothing but how much? 5/4. So if speed becomes 5/4, time becomes how much? Reverse 4/5, right? So speed becomes 5/4 means, the 5/4 of the speed, time has to become 4/5. 4/5 of the time means how much is it less by? It is less by 1/5. So numerator in the previous problem was more by 1. Here the numerator is less by 1. So time is less by what? So 1/5 of the time less that the person is taking. So 1/5 of the time is how much? 1/5 of the time is t 15 minutes. So t has to be equal to 75 minutes. Yeah. So same setup, same 15 minutes, same 25%, 25% more or 25% less, 25% less the speed, that is 75%, 3/4, 4/3, 1/3 more, 45, 25% more, 5/4, 4/5, 1/5, that is 15 and 75 minutes. Yeah. So this is something that has to happen without making a mistake, right? So quite a few of you got 75, but quite a few of you also put in 60 and 90, right? So that means there is a major issue at this particular level. It's a very, very basic move. I suppose it's very, very clear. So you always need to say, convert the increase in percentage into a fraction. 25 increases 125, that is 5/4, 4/5, 1/5 less, and that 1/5 is 15 minutes and he is 75. And you cannot have calculation mistakes on this also, right? So this is the most basic move. We'll just end with one last question on this. Do this. I just thought I'll give you a slightly uncomfortable number. 78, 54, 60, 78, 72, 78. Yeah. So 30% faster. 30% faster means 130%. 130/100. You can only reduce it to how much? 13/10. Speed becomes 13/10 means time becomes reverse 10/13. 10/13 means how much is it less? It's less by 3/13. So 3/13th of the time, 3/13 of t is equal to 18. 3 goes 6 times, 13 6 are 78. So that is how this problem works out. Speed becomes 130/100 or 13/10. So time becomes 10/13. Yeah. And 3/13th earlier is nothing but 18 minutes. So 3 cuts 6 times and 13 6 are 78. Right? So that is how this goes. Even if the number is slightly uncomfortable, you should be able to pull it out. So when I say this is the basic move, again, this has to be done, all the 3 problems, without putting pen on paper, under 20 seconds. So that is a basic fitness criteria that is required for this particular thing. Right? Now that we have the basic move in place, we'll take it slightly, right? A slightly difficult, not a very difficult problem, a problem that we'll look at a different variation. Actually, it's still the basic. We'll just look at a variation. Look at this one. What's the answer on this one? 54, 7.2, 36, 13, 54. Some answers a bit weird. Yeah. But yeah, 54. Yeah. So again, always whatever time you're comparing with. So I'm not saying it should be old time or new time, whatever you're comparing with. So the old time was how much? 90 minutes. New time is how much? 75. So time is becoming how much? 5 by 6, right? Say 90 minutes to 75 minutes. So 75 by 90 is how much? 90 minutes. So time is becoming, speed has to become 5 by 6. Time is coming down, right? From 90 minutes to 75 minutes. So speed has to become 5 by 6. So 1/6 of the speed is nothing but that delay of 9 kilometers. So the actual speed is 54. So whether I'm doing time or whether I'm doing, speed, so that has to, yeah. So I think I made a small mistake in this first thing, typing it out. It's 75 to 90. From 75 minutes, the time is becoming how much? 90 minutes. So time is becoming 6 by 5. That means speed has to become 5 by 6. The 1/6 is reduced. That 1/6 is 9 kilometers. That speed is 54. Okay. Now, this is the slightly advanced problem. So good. Of those of you who have answered, 1/3 have got it right. 120 kilometers per hour. Right. I think the rest have had this thing. So let's see how this problem goes. Right. Now, how do we go ahead and solve this again using that same ratios thing? What does the problem say? At some point of time, the car develops engine trouble, right? So car develops engine trouble and it goes at what speed? It goes at 2/3 of the speed. And because of that, it reaches at 3:12 p.m. That is the basic situation, right? Some problem, it becomes at some point, it develops trouble and it goes at 2/3 the speed, reaches at 3:12, right? Had that problem occurred 48 kilometers later, right? So instead of say at whatever point it occurred, if it occurred 48 kilometers later, they would have reached that the car would have reached at 3 p.m., right? So there would have been a 12-minute saving, right? So what is happening in this problem? If we remove everything else, what we are saying over this 48-kilometer distance, because the speed became 2/3 over this 48, it took 12 minutes more, right? Because of this, say 48 exactly in this 48 kilometer distance, because the speed became 2/3, the time that was taken became 12 more. So if they did not have this 48 kilometers was not traveled at 2/3 the speed, 12 minutes could have been saved. So now what do we know over this 48 kilometers? What is the story? Time is 2/3. Now, if time is 2/3, speed is 2/3. If speed is 2/3, we know that time has to become 3/2 over that particular distance of 48, right? The speed has to become, time has to become 3/2. 3/2 means how much more? Half more. Said numerator is more by 1 of the denominator. So half more. So it's taking half the time extra. This half the time is extra is nothing but this t is equal to 12 minutes. That 12 minutes delay, half the time that I'm taking extra is nothing but that 12 minutes. So the actual time that I should have taken is 24 minutes. So these 48 kilometers, I should have traveled in 24 minutes, but because the speed became 2/3, my time became 3/2. I took half the time more, which is 12 minutes. Actually, I should have taken how much? 24 minutes. So it actually covers this 48 kilometers at 24 minutes. So what is the speed? 48 by 24 into 60, 120. Right? Seems like a big problem if you can try to write an equation and everything else, but if you look at the ratios, this becomes absolutely smooth to solve, right? Is this clear? This particular problem? Yeah. Once again, the last step. Okay. So we know that what happened. Okay. Cool. I'll explain it once more. So we know that normally when wherever that issue happened, that speed became 2/3, and because of that they reached at 3:12. So saying that if for 48 minutes more, 48 kilometers more, if it had gone at its usual speed, they would have reached at 3 o'clock, right? So for this 48 kilometers, because of that speed becoming 2/3, they lost how much? 12 minutes, right? So because of that speed becoming 2/3, the loss of time was how much? 12 minutes over this particular distance of 48. So if speed is 2/3, we know speed and time are inversely proportional. Time has to become how much? 3/2. 3/2 means how much is extra? Half a t is extra. We always were doing 4/5 means 1 less than the denominator, so 1/5 lower. Similarly, 3/2 means 1 more, so 1/2 or half the time more. So half that time is 12 minutes. If half the time that's taking extra is 12 minutes, the actual time that the train normally takes is how much, or the car normally takes is 24 minutes. We need to calculate the speed. What is the speed? 48 kilometers, it travels in 24 minutes. That 24 minutes, 24 is in minutes. We need the speed in kilometers per hour. So it's nothing but to convert that minutes into kilometers per hour. What will we do? 24 divided by 60. So it's nothing but 48 divided by 24 divided by 60. So hence that 60 goes up, and hence it's 48 by 24 into 60, or 120 kilometers. Yeah. So that last part is that 24 minutes. So in all the problems previously also, we calculated what was the original time, what was the original speed. So it is that same thing. They gave an entire big story, but essentially it's saying over these 48 kilometers, if the speed had not fallen, we would have saved 12 minutes. We lost 12 minutes over these 48 kilometers, right? So hope it is clear right now. Yeah. Now, we'll take the same problem, right? More or less the same thing. This time, I want all of you, I'll give you time. So it's those of you who have issues with this, take your time. There's only a small, but the problem is essentially a mirror problem, but we've added a few things here and there, right? So I want you to take your time and solve this problem correctly, the next problem. So these are the results. 44% have marked option 3 and 20% have marked option 4. Okay. Now, if you see, this is the same problem as the previous problem. What happened in the previous problem? Instead of an accident, I'm sorry, I shouldn't say accident. Instead of the problem happening at point X, if it had happened slightly, what you call later, right? So if it went at the normal speed for slightly later, we could have saved so much time, right? Instead of actually giving that distance, they've just given different starting points here, right? Essentially the same problem. And they're asking you one more question. What is the total distance as well, right? Now, if we go to this problem, same thing. If the problem occurred at 18 kilometers, hence the delay was how much? 45 minutes. If the problem occurred at 30 kilometers, the delay would have been how much? 36 minutes. So if for 12 kilometers, the car went at its usual speed, right? For those 12 kilometers, 30 minus 18, 12 kilometers, it went at its usual speed. It would have saved how much? 9 minutes, right? Because the speed reduced over these 12 kilometers, it lost how much? 9 minutes, 45. Now, if you look at it, this 12 kilometers, if, because of the speed loss, how much did it lose? 9 minutes. Now we look at the problem. Here, how much is the speed becoming? Speed is becoming 4/5. Speed becomes 4/5 means time becomes how much? 5/4. 5/4 means how much is the time extra by? Time is extra by exactly 1/4. So 1/4 is nothing but that extra time of 9 minutes. Now 1/4 is 9 minutes means T is how much? 36 minutes. So we know that time is 36 minutes. Now how much distance in 36 minutes? How much distance does it normally cover? 12 kilometers. 12 kilometers in 36 minutes. What's the speed? 12 by 36 into 60 is equal to 20. Same thing like the previous problem. It was in minutes. The time was in minutes. So you have to do 12 divided by 36 by 60, 20. So the moment we get 20 kilometers per hour, and you saw that there is an option called 20 kilometers per hour, you would have gone ahead and at 20, it's not miles per hour, that's kilometers per hour. The, the international, the software keeps the PBT keeps converting it into miles per hour. It's kilometers per hour, right? Now they're also asking you one more question. And what was that one more question that they were asking? It is, what's the total distance? So obviously, since the speed is 20, first and second one are not the answer. It has to be either 20 kilometers per hour or it has to be none of the above. Now, you need to check whether the total distance is 90 kilometers. Do you want to write in there? Are they asking you to find the distance? So you need to check whether it's 90. Right? So you don't need to find out what the actual distance is. You need to check whether it's 90. If it's not 90, you can go to none of the above, right? So if you want to find the distance, you will end up writing an equation. That is again a long way out. How do you check this? You know the entire story, right? For 18 kilometers, it went at its usual speed. After that, the speed became 4/5 and it ended up being 45 minutes late. All you need to do is check that. Now, whether that 90 kilometers at 20 kilometers per second per hour means how much time? 90 by 20, 4.5 hours. And because of this, the delay should be 45. But the normal time is 4.5 hours. It should have a 45-minute delay. What's happening in this particular situation? 18 kilometers at 20 kilometers per hour. 18 kilometers, it's traveling at the first 18 kilometers, it's traveling at its usual speed, 20 kilometers per hour. How much time will it take? 54 minutes. It is, say, 18 by 20. In 1 hour, it travels what you call 20 kilometers. So for 18 kilometers, it will take 9/10 of that, 9/10 of 60, that's 54 minutes. So this one we know. So that 8, so this much is traveling. Now this is where the problem occurs. The problem occurs, and the next 72 kilometers, it's going at how much? 16 kilometers, which is why 16 kilometers per hour, 4/5 the speed. 4 by 5 of 20 is how much? 5 goes 4 times, 4 4s are 16. Right? So 72 kilometers at 16 kilometers per hour means it needs to take 4.5 hours. Now, what is the total time? 18 kilometers 20 is 54 minutes, and 72 kilometers at 16 is how much? 4.5 hours. So how much is the delay by? If the distance is 90, delay is by 54 minutes. But according to the problem, what is the delay? 45 minutes. So should 3 be the answer? No. The answer has to be 4, none of the above. Right? So they gave that very nice trap because it is the same problem, make a slightly different problem on that, gave 20 because you got 20, you would have gone with 3. So we just checked. Do you guys want me to repeat any specific part here? Yeah. The distance part? Okay. Yeah. The last part. Okay. So they're asking us to find the distance. They're asking us to find the distance, but they're giving one option as 90 and the last one as none of the above. So all we need to say is that if the distance is 90 and the rest of the story, everything is happening as usual, then at 20 kilometers per hour, will the delay be 45? We need to check, will the delay in this situation be 45? If the delay is exactly 45, normal time is 4.5, but because of the speed decrease, the delay is 45 means 90 has to be the answer. If the delay is not 45, then 90 is not the answer. Now I start, what is the situation? For 18 kilometers, it's traveling at the usual speed only. There is no problem with the car. 18 kilometers at 20 kilometers per hour, how much time will it take? Distance by speed, 18 by 20 into 60. That is nothing but 9 by 10 into 60. 9 6s are 54. 54 minutes is what it will take. 9/10 of an hour or 54 minutes. So for the first 18 kilometers, when it's traveling at its usual speed, it takes how much? 54 minutes. What is happening to the car here? The car is, there's some problem and the car is going at 4/5 the speed for the rest of the journey, right? So if 90 is the distance, the rest of the journey is how much? 72 kilometers. 4/5 the speed is how much? 4 by 5 of 20. That is nothing but 16. So if it is taking the rest of the journey, it's covering at 16 kilometers per hour. How much time is that? 72 by 16. 72 by 16 is nothing but how much? It's 4.5 hours, right? 72 by 16 kilometers per hour. In terms of hour, we don't need to convert it into minutes, right? So you have this at what you call for 4.5 hours. Now, what is the difference that we are talking about here? The difference, if you look at what's the total time in this situation, 54 minutes for the first 18 and 4.5 hours for the total. According to the problem, how much should the delay be? The delay should be 45. But in this situation, you're getting the delay as 54. So hence 90 cannot be the answer. It's someone. So again, can you explain how we took 9 minutes as the extra 1/4 part of the time for 12? Can I explain the speed calculation? Absolutely, we can do that once more. Not an issue, right? So what are we seeing here? I'm saying what the problem is saying that for these 12 kilometers, instead of say 18 kilometers where the problem happened, if the problem actually happened 30 kilometers later, that means for these 12 kilometers also, if my speed didn't go down, if I traveled at my usual speed, I would have saved how much time? I would have saved 90 minutes, 9 minutes. Instead of being 45 minutes late, I would have been 36 minutes late. But because of over this 12 kilometers, the speed is going down, I'm losing how much? 9 minutes. So how much is the speed becoming over this 12 kilometers? Speed is decreasing by 4/5, right? So 4/5 of the speed, if speed becomes 4 by 5, then time becomes 5 by 4. How much is that extra? 1/4 is extra. That extra time is nothing but that time that was, that was lost in that case, right? So that 1/4 is nothing but that 9 minutes. 1/4 of t is 9, hence t is 36 minutes. So for these 12 kilometers, it should have covered in 36 minutes only, but because it went at 4/5 the speed, it took that 9 minutes extra, right? So what is that distance? 12 kilometers. What is the original time that it's supposed to take? 36 minutes. So 12 by 36, but it's 36 is in minutes, so 36 by 60, so 60 goes up, and that is how we got the 20 kilometers per hour, right? So once we got that, we just needed to calculate the total distance. So they said, what is the distance also? So instead of actually calculating the distance, I just checked with this distance of 90, is that delay of 45 matching or not? I can check the delay of 45 after 18 kilometers, or I can check the delay of, say, 36 minutes after 30 kilometers also. Either case, the delay should match at 9, if the total distance is 90. But we are seeing that if we execute that whole thing and see, the delay is not matching, the delay is 54 minutes. But if the problem happened at 18 kilometers, the delay should be 45 minutes according to the problem. At 90 kilometers, I'm getting 54 minutes. So hence, it is none of the above. How do we calculate the actual distance? For that, we have to get into an equation, right? How do you calculate that actual distance in this thing? Take that actual distance as x, right? For the first 18 kilometers, it's traveling at 54 minutes. So that time is 54 plus what is the rest of the distance? X minus 18 kilometers. X minus 18 kilometers is the remaining distance. That how much time is it taking? You need to calculate. That is divided by what speed the rest of the distance is going at, 16. So X minus 18 divided by 16, that should be equal to total time is how much? The actual time, it's taking 45 minutes more. If there was no speed problem, the whole distance of X divided by 20, you will get the total time plus 45. So you need to solve this whole equation, right? So actual time should be X by 20. That is increasing by 45. That should be X by 20 plus 45 on the right hand side. Left hand side is 18 kilometers at 54. So you anyway know that 54 minutes plus X minus 18 divided by 16. So you have to solve that. Always the faster method. There is no point. They've already given you the number that is there. You just need to check instead of trying to calculate. Do you want to solve that equation or do this calculation? I would always do this calculation and finish it off instead of solving that equation. Yeah. Is this clear now? Yeah. Okay. The equation alone, yeah, equation, just think through, yeah, we don't need to actually find the actual distance. We can, eliminate, there. Somebody said that it's 45, what do you call, if you ask me, all these parts have to be done without the pen. Yes, I would do it, without a pen. How the delay, see, what we saw is that the total delay is not 45. In the first case, the delay was 45. In the second case, the delay was 36. So the extra time is nothing but 45 minus 36, 9. Right? So that is the whole this thing. Because we don't know the whole distance. They're only talking about if it happened so many kilometers earlier. So yeah, ideally all these parts have to be done without a pen. Maybe not today, but if you start trying, that will happen, right? Once you know the setup, because these numbers are also very, very comfortable, right? And those of you, who look at those toppers and say, how is this guy scoring that, 230, 240 or whatever, they are not actually sitting and doing all of these calculations using pen and paper. Try it out. Say later when you watch this video, even if you try to do it mentally, it's not that tough. It'll just seem harder, right? But if right, but it's actually fairly actual. Right? So we've seen two problems of more or less the same type using this. Some of you, if you're I know there are quite a few people watching. So some of you might find that you would need a bit of repetition. The recording will be available. You can go over it again and you will get it. Right? Essentially what we're saying is that particular part, if there was no problem, they would have saved so much time. So because of this problem, we lost so much time. That's it. So that problem is nothing but the decrease in speed. 4/5 speed, so 5/4 times, so 1/4 time is 9. Right? So by now I do it that way. So it's just super fast in terms of the way you go. Right? Now, we've seen all of it in time, speed, distance, right? So we've looked at a basic move in time, speed, distance. We'll come back to time, speed, distance. Now the same thing can also apply in time and work, right? Because when I say speed, right, I say my speed is going from 15 to 30. My speed is doubling, right? If I say I have 15 men to do a work and now I have 30 men to do a work, my capacity is doubling, right? So speed and capacity are the same thing. Just like from 15 to 30, if I increase my speed, my time will be halved. If I increase the number of men from 15 to 30 also, my time should be halved, right? So that is the basic move that we're talking about here. So if we look at this problem, just we can just do this orally. 5 men complete a piece of work in 25 days. How many days will 15 men finish the same piece of work? Capacity is tripling. The men is becoming 3 times, or speed is becoming 3 times. So time becomes how much? 1/3, right? So you don't need to think of man days, this, that, whatever. Capacity or speed triples. So time taken becomes 1/3 or 25 by 3. Right? Very basic, same thing, nothing different. You don't need to do 5 into 25. I'll calculate total math. Essentially, you can understand it logically what is happening. My capacity is tripling, so time will become 1/3. Right? The whole idea is that you become comfortable in that logical space instead of thinking of it like a formula or this thing. Everybody know it's as close to real life as it can get in terms of conception. Right? Now we'll change the problem slightly. Now, same thing. So as I said, somebody said M1W1 is equal. So I just want you guys to stop it. I'm not saying doing M1W1 is equal to M2W2 is a bad thing, right? But do we need to think in terms of M1W1, M2W2? Right? Do we need to speak like a different language or algebraic language? We don't need to, right? Number of capacities tripling, so it's just becoming half. That's it. So what I want you guys to be able to do is be in that reasoning space, right? Let's try to be purely in that reasoning space. Now let's look at another problem. If a man takes 15 days to finish a piece of work, then what part of the work will be done by 2 men in 5 days? Okay. Now, in 5 days. So time is becoming how much? 1/3. If time is becoming 1/3, or in 1/3 the time, how much work will I do? I can do only 1/3 the work, right? In 1/3 the time, I will finish 1/3 the work, right? But I am not there. I have double the capacity, 2 men. So I can do twice the work, which is 2/3. Right? As simple as that. If you're looking at 1/3 the time, I can do 1/3 the work. But in this same time, I have how many number of people? I have twice the number of people, 2 men. So twice the capacity, so 2/3. Right? I don't need to do anything more or less. Right? Fairly simple so far, not an issue at all. Right? This fine? Yeah. This part. Two-third of what? So no, they're asking what part of the work will be done. They're not asking time. They're asking just what part of the work will be done. 2/3 of the work will be done, right? Yeah. So the thing is, we don't need to get into any other sort of calculation. In 1 day, this way we'll do 1/15 of the work. In 5 days, he'll do 5 into 1/15 of the work. And essentially, it's all the same thing, right? In 1/3 the time, you're going to do 1/3 the work. And to double the capacity, so do 2/3 the work. That's what the question is asking. Right? Now we'll slowly take it to the next thing. Do this. So we are doing now. What I want you to think of is that is time and work. This is time and work. That was time, speed, distance. We don't need to think of those things. If you look at, say, the Indian books and Indian syllabus, we will have different names for everything. This is time and work, that is time, speed, distance, and then we'll say in time, speed, distance also there's a circular races problem, and then we'll say there is a work pipe and system. That's a different, as in a work pipe and system, a different thing, right? But if you look at the GMAT book, they call all of these problems by the same name. They call them rate problems. Why do they call them rate problems? Because it's not a different concept at all. So what is happening here? Some men can do a piece of work in 60 days. 8 men more join. So their capacity or speed is increasing. And then the work can be done in 10 days less. That means 10 days less means work is getting done in how much? 50 days. So from 60, it's becoming 50. 50 by 60 is how much? 5 by 6. So if the speed is becoming, time is becoming 5 by 6, that means speed has to become how much? 6 by 5. Time is becoming 50. From 60, it's becoming 50. So time is becoming 5/6 means speed has to become 6 by 5. 6 by 5 means how much is the speed extra by 1/5? That 1/5 extra is 8. So total number of people are 40, right? So 60 days to 50 days, time becomes 5 by 6. So capacity becomes 6 by 5 or 1 by 5 more. That 1/5 more is nothing but 8 people, and X is nothing but 40. Clear? Their work can be done in 10 days less. 10 days less. So always take the base. What is the current? What is the first time? The base time is how much? 60. What is it changing to? 50. So you're always calculating everything to base time and base capacity. Base capacity is 60. That has become 50, right? 50 by 60 is how much? 5 by 6. Time has become 5/6 means speed has to become 6 by 5. 6 by 5 is nothing but 1/5 more, 1/5 of the original more extra, because my capacity is increasing by 1/5. I need what, I'm able to do it in lesser time, right? 10 days later. So 1/5 of my capacity is what I have extra. So that is here, right? So yes, you can use an equation absolutely, so you don't need, so capacity, speed, all of them are the same things, there is no difference. As I said, the difference is here. Actually, there is no difference. Here it's your accelerator, there it is more men that you're driving, right? 40 including the 8 men, 40 is the original value. So that's what they're asking. So they're asking about what is the original number of workers. So that's what they're asking. What is the original number of workers, right? Yeah. So we will get into slightly. So what about, how about 3 or more parameters? We can do 3 or more parameters also, not an issue. So we'll be doing a few things, right? This is not to say that the equation won't get you there. The equation can get you there, right? But equation involves what? Writing an equation, cutting off a few things. This method is more bloodless, right? You're straight away saying that time is becoming 5 by 6. So speed has to become 6/5. That means 1/5 more capacity. So 1/5 of extra capacity is nothing but 8. So actual capacity is 40. Right? It's always increasing or decreasing with respect to the original capacity, right? 1/4 of what? 1/4 of 1/5 more of what? 1/5 of the original capacity, right? Whatever is the base of speed and whatever is the base of time, whatever is the situation you take, everything else will be the original value of that. Now we'll do a few more problems along this. Look at this problem. So all of these are classic time and work problems that are usually done in one method. I am trying to see, can we think of slightly a different method? Look at this. Okay. Now, how do we do this problem? I'll first show you the traditional method. 10 men started a piece of work and after some days, 4 men left. As a result, instead of 40 days, it took 50 days to finish the job. After how many days did the 4 men leave, right? So in this particular problem, I'm just showing you that we can use ratios here also, but man days is as effective a method. I just want you to show that it is versatile if you think you can use it here also, right? But what is the man days concept? Normally, how many days does it take? 10 men, it will take 40 days. That means the number of man days required is 10 into 40, you will need 400 man days of work. Whenever 400 man days of work is done, the job is done, right? So they're asking you that 10 men have worked for X. So now we are saying that, and in the new situation, some people are leaving after this. After how many days did the 4 men leave? Let the 10 men have worked for X days, or let the 4 men have left after X days. Both are the same, right? So what is happening? The number of man days for this job to get done is 400. 10 people are working together for X days, and the rest of the 6 people are working for 50 minus X days. This should be equal to 400 because that is the number of man days that is required, right? Whenever 4 man days of work is done, the job is done. If 10 men are doing it, it is fewer days. If more men are doing it, it is fewer men are doing it is more days. But the job is only 400 man days, right? So 10 men working for X days plus then the remaining men, 6 men working for how many days did it take? 50. 50 minus 6 is equal to 400. So if we solve this, we get 4x is equal to 100 or x is equal to 25 days. So after 25 or only 25 days, all the 10 people worked, and after 25 days, these 4 people left, right? So this is as the most traditional method or the best method. Is this clear, right? But this is with the help of equations. Now, how can we do it without the equations, right? Same thing, same concept that we're thinking of. 10 men, 40 days, for some days, all of these guys are working 10 men, and for some days, only 6 men are working. Exactly like after some point, there was an engine trouble. And after the engine trouble, the car speed became 2 by 3rd. So similarly, after a particular days, the speed became how much? 6. And because of which, how much extra time was taken? 10 days. Now capacity becomes after here how much? 6 by 10 or 3 by 5. If capacity becomes 3 by 5, so the time becomes how much? 5 by 3. How much is extra? 2 by 3. So this 2 by 3 extra is nothing but this 10 days. So 2 by 3 is the extra days that we are taking, 15 days, or T is equal to 15 days. Now this T is equal to 15 days is what T? The time over this duration, because this is where the increase has happened, right? Because till here, everything is the same. This is where the car trouble started. So normally this should have taken 15 days, but it took 10 days extra. So we know that if this T is 15, so what about the remaining this thing? That is 25. Right? So this T originally should have been 15 days. This 10 men, if 10 men had worked, it should have taken 15 days. So the remaining part is how much? 25. Is this clear? Once again, yeah, how we got to 25. Okay. Now, till this break happened, right? This is where people left, right? Till then, in the original situation and the new situation, will there be any extra time taken? No, it will be the same time taken, right? So this original time, so whatever was the part from this part, it should have taken and finished in 40 days. This part, only this part increased by how much? This part increased by 10 days. Because what happened during this part, from this point on, the capacity became 6 by 10. Because the capacity became 6 by 10, for this part, the speed became 3 by 5. So time that you normally take, that time became how much? 5/3. That time became 5/3 means how much is extra? 2/3. 2/3 of the normal time is extra. So 2/3 of the normal time is extra. And how much is that extra? 10 days. So 2/3 of T is 10 means T is square, T2 goes 5 times T is 15. So this normally takes 15 days. Because the speed became 3 by 5 and time became 5 by 3, it took 2/3 extra. 2/3 of 15 is how much? Do this 2 by 3 extra. 2 by 3 into 15 is how much? 3 goes 5 times 10 days. Right? So this actually took that 10 or 10 days extra. So the original time for this particular part was how much? 15 days. So if the original time for this part is 15 days and total part is 40 days, so at what point did they leave? These guys left after 20 days. Yeah. Is this clear now? Rasteen says extra 10 days because 4 men left. 4 men left. So when I say my speed decreased by 25%, then what is the speed becoming? What is the leftover speed? Because I need to work with what my leftover speed is. My left speed decreased by 25% means my speed is how much? 75% or 3 by 4. And hence my time is 4 by 3. Similarly, 4 men left. After 4 men left, what is my current capacity? What is my current speed? That is 6. So what is it? Just like 25% decrease means 75% speed. 4 people left means 6 men is the speed, right? That clear? Why did I take, yeah, so 15 days, so this portion from where the problem occurred, this problem, ideally this part should have been done in 15 days. Because at this point, people left at exactly this point. This point took how much? Because its capacity became 3 by 5. For this, from this point onwards, from this point to here, this capacity became 3 by 5. So time becomes 5 by 3. 2/3 extra of what it normally takes. So 2/3 extra of what it normally takes. How much? Because this extra is only because from this point. From here it should have taken this. So that is nothing but the 10 days. So normally, wherever the problem occurred, from that day onwards, it should have taken, normal time was 15 days, right? So for normal time, for that portion from whenever they left, that was 15 days. So if the normal time is 40 days, these guys left after how many days? 25 days. Right? It's exactly the same car problem, right? After 18 kilometers, there was a problem, or rather after traveling a distance of so much, there is a problem and time became 2 by 3. That means for that time, speed became 2 by 3. So that part after 18, the time required became 3 by 2 or whatever. Yeah. Clear? Yeah. we can, yeah, we can definitely, we want, so just going back to the question. This was the question. Yeah. So 10 men started a piece of work, and after some days, 4 men left. After some point, 4 people left. And as a result, instead of 40 days, it took 50 days. Right? Till one point, there was no issue. At some point, 4 men left, and because of which the total time increased. Now, obviously, the total time increased from that point only, wherever people left. Right? So that 10 days extra was because of during that duration, there were only 6 men. No, 6 men did not. 6 men took, 6 men took 25 days after the 4 men left. Right, right. What exactly is 15 days? Jaya, 15 days is the exact time that wherever that point that people left, no, that 6 men left, if those 6 men had not left from that time on, right, from that time on, it needed 15 days more to finish the job, wherever those people left, right? But because those people left, instead of 15 days, they took how much? They took, say, what you call 2/3 extra of those 15 days. So 2/3 extra is how much? 2/3 of 15. They took 10 days more. That 10 days extra is because instead of 15 days, because the capacity became 3/5, the time became 5/3, and they took 2/3 extra, 2/3 more than the normal 15 days. 2/3 into 15 is how much? You'll get back the same 10 days, right? So from wherever the problem occurred, that normally should have taken some time. That time became how much? 5/3. 5/3 of its usual time, right? 5/3 of usual time means that time increased by 2/3 of itself. And that means that time, the 2/3 of the original time is nothing but 10 days. So I know it will seem, that a lot of people and, what you call, would have done this. So you will, get it a bit later, right? So now, and see, sometimes for those of you for whom this is absolutely brand new, there are about so many people, more than 1,000 people, attending this. Different people will have different paces of understanding, right? And the best way is when you watch it later. You will, and if you spend time by your own, that is how you figure it out, right? So it's just about, so you would have to maybe go through this whole thing again, but just think through. So from wherever my problem started, that is where my speed decreased. We'll move ahead, otherwise we won't finish on time, right? So this part normally should be done in 15 days. Total job is 40 days. That means the point where the previous part is 25 days, and after 25 days, those guys left. Now, we'll go into slightly a different area. So this is I like, for me, this part is a real fun part, because I don't know whether people normally solve it using this method, right? So try this problem. So 44% of you got the answer is option 2, 6. That is the right answer. But the key on this question is not the answer, but how do we do it? Normally, how do we do it? Using ratios. That's the fun on this question, right? Normally, we take R does a job in 36 hours, S does the same job in 18 hours. If they're working together, 1/36 plus 1/18 and all of that. So that's one way of doing. Nothing wrong against that method of doing, right? But can we use ratios here? Because I want to see how far can we take ratios, right? So let's look at the same type of concept and try to do this. Right? R is taking 18 hours and S takes 36 hours individually, right? Okay. Now, S takes twice the time as R, right? If S takes double the time of R, that means what is S's speed compared to R? S's speed is half of R's speed, right? So S takes twice the time as R. So S has half the speed. So if S is joining R, right? So when joined by S, R's speed becomes R plus somebody who is half as fast as him, right? Half R. So R's time, speed becomes how much? 3/2. If R's speed becomes 3/2, the time taken by R becomes how much? When joined by S, R will thus take 2/3 the time. How much time does he normally take? 18 hours. So 2/3 of the 18 hours is how much? When S joins, when they're working together, it is 12 hours, right? So if R is joining S, the time that is required is 12 hours. They're saying how many machines of each type are required to finish the job in 2 hours. If one machine each they're working together, they'll take how much? 12 hours. You need to finish the job in 2 hours. 2 hours means time is becoming 1/6. If time is becoming 1/6, how much should capacity become? 6 times. Yeah. No fraction addition, nothing. We're purely moving in the space of, say, solving it using speed, right? We took R as the base. S is how much? S is takes twice the time. If he's taking twice the time, that means he's half as fast as me. So when he's joining me, I am there, and somebody who's half as good as me is there. 1 plus half is how much? 3/2. So my speed is becoming 3/2 times. If my speed becomes 3/2 times, my time that will take will become 2/3. Normally I take 18 hours. So 2/3 of 18, that will become 12 hours, right? Now, the fun part is you can do it the other way around also. R is taking 18, S takes 36. You can solve the same problem from S's perspective also, right? So S normally takes, R takes half the time as S, right? So if I'm taking from S's perspective, I do the job in 36 hours. This guy does it in how much time? Half the time as me, R. That means R is twice as good as me. So from S's perspective, if R is joining me, I am getting somebody who's twice as fast as me. So whenever R is joining, when joined by R, S's speed becomes, this is not 2R, this is 2S. S's speed becomes 2S because somebody twice as fast as me is coming in. So my total speed becomes 3S. So S's speed is becoming 3S. So if S's speed is becoming 3 times, his time will become how much? 1/3. How much does he normally take? 36. 1/3 of 36 is the same 12 hours. So when they're working together, whether you take S's speed and calculate the time together, or whether you take R speed and time together, you will get the same 12 hours, which is nothing but 1/18 plus 1/36. Now you can do that 1/18 plus 1/36 and get the answer, or I'm saying you can also do this. So one machine of each type, one each are working, they take 12 hours. Now they're saying, as just to reiterate that last bit once again, they need to finish the job in 2 hours. Time has to become 1/6. So capacity has to become how much? 6 times 6 machines each. Yeah. Is this clear? Yeah. Yeah. So you can take the LCM and do, so we can take LCM 36, I can do all of that. But I'm saying that if we can solve it in what seems like a common sense space between us, right? So if we can solve it using that, common sense space, then the problem becomes easier, right? So just a minute, we'll go. So people wanted to see the question again. Question is nothing, question is very simple. 2 machines are there. One is doing a job in 36 hours. One is doing the same job in 18 hours. They are working together, right? We need the same number of each type of machine. So how many machines of type R, same number of each type of machine are required to finish the job in 2 hours. So they're saying that if both of them are working together, how many machines of each type are needed to finish it in, and we want the same. It's not like I want more S and fewer R. I want the same number of both. So the normal way of doing is 1 R and 1 S will do the job in how much time? 1/36 plus 1/18, you do that and you'll get, or you take the total job as 36 and you will get that answer, right? So you will get that 1 R and 1 S will finish the job in 12 hours because they're saying we need to finish the job in 2 hours. Time is becoming 1/6. We need 6 R's and 6 S's. We need 6 machines of each type. Right? So that is the problem. Right? So how did we solve it? We solved it saying that, okay, this machine is doing it in 18 hours, this machine is doing it. We converted the speed into, each of these cases, right? Now, so here we solved the problem in terms of R, then we solved the problem in terms of S. Basically, it's nothing. Whoever are you taking as the base speed and somebody else, what we did, base time, base speed. So similar, this thing. So whether you take R or whether you take S, in both cases, so if I take, say, S as the base. S takes 36 hours. This take 18 hours. That means he's doing it in half the time. That means he's twice as fast. So if R is joining S, then he's twice as fast, means S's speed is becoming, this is not R, S plus 2S, that is 3S. So if S's speed is becoming 3S, then S will take 1/3 of the time that he normally takes. He normally takes 36 hours. So 1/3 of 36 hours is 12. So essentially when they're working together, that's the time that they take. Right? Both of them together, one machine each 12 hours, they need to do it in 2 hours and 1/6 the time. And see. Now, the key question is, how do we, if the numbers aren't proportional, then what? See, if co-prime numbers, if the numbers are co-prime, then anyway, it's the same headache whether you do it in equation, in 1 by this thing also, there also, right? So, no, it implies how many machines of R only. No, it says if you need the same number of each type of machine, then how many type of R is required? It's not R only, same number of each type of machine you're using, right? Yeah. Now, it says that if you're using both machines together and you need to use the same number of each same number, as many R as you're using, you need to use so many S, then how many types of, essentially, they've just made the question slightly, verbally complicated, right? So yes, it's when do you use it, when do you not use it? So if you have, say, both the numbers are absolutely, say, this, what you call twice or this, before that, a student asked me much earlier, it asked me a good question. Sir, when I'm doing it with this S speed, it seems very easy, right? Because it's S plus 2S, 3S, so 1/3. But when I did with R speed, it seemed complicated. 1 plus 3 by 2, 2 by 3, what should I do? So whenever you're trying to use this method to calculate time taken together, what you should do is, when using ratios to solve problems involving two people working together, start with the slowest person's time, right? That can help, help you to avoid fractions if the numbers are favorable, right? Suppose, because I'm taking the slowest person, right, the other guy will always be faster. That means his speed will always be a multiple. S is taking 36 hours, R is taking 18 hours. Half the time, right? S is the slower guy. Half the time means how much? Twice the speed. So that means it's always becoming multiple, S plus 2S. But if you take the fastest guy, everybody else's speed will be a fraction, and hence you have to add fractions. Just helps you avoid fractions if it is, as I'm saying, if it's a favorable situation. Right? This is, again, I'm just introducing an approach to show that these ratios can be used in different spaces. Right? We'll do a few more problems. It's just that what is normally not done, I'm not saying you should stop solving your usual methods right now or whatever. But all I'm trying to get at is that you can use what you call, we'll discuss all of this at the end. Will the numbers always be proportional? See, if anyway, if you're doing the 1 by 36 plus 1 by this thing, it's the same thing. You anyway need whether they're proportional or not, and that method also doesn't matter, right? But I'm trying now. One important thing, you can use the efficiency method also. You can use all methods. You can use, but you can be very, very comfortable using the traditional method also. I have absolutely no. One thing you need to, what you call, that you need to remember very, very, importantly, is that I am not teaching a different concept. I am teaching the same thing. It's the same time, speed, distance, right? So time, speed, distance, at the core of it, the things don't change, right? We're just trying to extend that rate problems method across the whole thing and say, it's like saying that I'm giving you one more ammunition, right? And we'll see when it will be useful and when it won't be useful, right? So some people find it very comfortable. At least you know that this option is there. Suppose you're stuck using your traditional method, you know that, okay, this option is there for me to think. Yeah. So we'll discuss all of those things right towards the end. Let's do more problems now. So starting with the fastest person will always result in fractions. That's what we discussed. Right? Now, this is a slightly tricky problem. Take a look at this. Good. Bulk of you who solve this question, more than half of you got it right, 106. That's the right answer. Now, and how do we do this? There's a traditional method and whatever it is. So how do I process this question, right? So for me, this works best in terms of ratios, because what are they saying in the problem? P can do as much work in 3 days as Q can do in 4 days. So they're giving a relationship between P and Q. So I can get their speeds into play, relative speeds, ratio of speeds. Q can do as much work in 6 days that R can do in 5 days. Again, I can do with Q and R also, I can get their relationship. And if all three work together, the job is completed in 30 days. How long would it take for Q to complete the job independently, individually? So what do I know? P takes 3 days, Q takes 4 days. P takes 3/4 the time. If P is taking 3/4 the time, P is how fast as Q? P is 4/3 as fast as Q, right? That much is clear. When P takes 3, Q takes 4 days, P 3 days. So 3/4 the time, that means P is 4/3 as fast. Next one, Q takes 6 days, R takes 5 days. R takes 5/6 the time. So R is 6/5 as fast as Q, right? So when both of these guys are joining Q, what is Q speed becoming? When all three work together in terms of Q, the joint speed is, this is 4/3 of Q, this is Q, this is 6/5 of Q. You add this, LCM is 15, this is 20, and this is, 6 3 is 18, that is 38, plus this is 15, that's 53. So the speed is becoming, when Q is working, 53/15 times, when all three are working in terms of Q, right? If speed is 53/15, then time is how much? 15/53. 15/53 into X is equal to how much? What's the total time when all three are working? 30 days. 15 goes 2 times. 53 into 2 is 106. Yeah. So the problem itself is saying that please express me in terms of Q. So hence it has to be, ratios in terms of the best way to go about it. PQ days, I think 3/4 the time, so 4/3 as fast. 5 days and 6 days, 5/6 the time, so 6/5 as fast. Total speed of, with respect to Q, when everybody is joining Q, is how much? 50/3/15 of Q. And this 53/15 of Q is nothing but 30 days. So Q is 106 days. Is this clear, this problem? Yeah. All three working together part? Okay. Yeah. All three working together part, what are they saying? They're saying that when all three work together, they finish the job, and the problem says that what P can do in 3 days, Q does in 4 days, or R does in 5 days, Q does in 6 days. All three work together and finish the job in 30 days. How many days will Q take? So if all three are working together, and say, when Q is there, right? If Q is working, and they're saying how many days will individually Q alone take, right? If all three are working, there is Q. P is 4/3 of Q. This guy is 6/5 of Q. So total work when all three are working in terms of Q is 53/15 of Q, right? So if the time is 53/15 of Q, the speed becomes 53/15. The time becomes how much? 15/53 of Q, right? So Q normally will take 106 days alone. This is not 53/5, my bad, that's 53/15. So we can get, see that there can be many different methods. We can do whatever it is, right? So it's not as if I'm not saying, so we'll get to that later. I'm not saying one method is better or one method is this thing. But I'm saying that for me, I'll use ratios as the core method to play, right? Because it cuts across all areas. Instead of trying to remember specific patterns for specific problems, I like to work this way, right? And it's a very, and I'm working purely in that common sense space when I'm doing it. We have just a few more problems to solve. So 3 problems more to solve. So hence I want to go a bit faster. We'll discuss stuff at the end, right? So that's not an issue, right? Look at this problem. Okay. So yeah, it's 20/3. Now, first I'll solve it how I usually solve this. I'm looking at this problem and thinking, okay, Susie can do it alone in how much time? 2 hours. If Calvin is joining her, then if you help him out, then you can finish it in how much time if both of them are working together? 1 hour, 40 minutes. 1 hour, 40 minutes is how much? 1 plus 40/60, that is 2/3 of an hour. So 1 plus 2/3 of an hour is 5/3 of an hour, right? So from 2 hours, the time is becoming 5/3 of an hour. So 5/3/2, always new speed, new time divided by old time. Old time, Susie alone is 2 hours denominator, new time is 5 by 3. 5 by 3 by 2 by is how much? 5 by 6, right? If time is becoming 5 by 6, speed has to, Susie's speed has to become how much? 6 by 5. 6 by 5 means how much extra? 1 by 5. So 1/5 of the speed is nothing but how much? 1/5 of the speed is nothing but how much time is the finishing? If I take, I'll be out, then together I can, yeah. So 1/5. So speed is increasing by 1/5, right? So speed is increasing by 1/5. So who is this 1/5 increasing of speed coming from? This is coming from Kelvin, right? So Kelvin's speed is 1/5 of Susie's speed. Susie is taking how many hours? 2 hours. If he's 1/5 that's fast, that means he'll take 5 times the time. So Kelvin will take how much time? 10 hours. So Kelvin will take 10 hours. And now if Hobbes comes in, he'll say that Hobbes, along with Hobbes, he can finish it in 4 hours. So he alone takes 10 hours. And if Hobbes comes in, he finishes it in 4 hours. So time is becoming how much? 4 by 10. Time is becoming 2/5. If time is becoming 2/5, then speed has to become how much? 5 by 2. If speed is becoming 5 by 2, that means how much is extra by 3 by 2. So Kelvin's speed is 3 by 2 times, sorry, Hobbes' speed is 3 by 2 times the Kelvin's speed. 3 by 2 times the speed means 2/3 the time. 2/3 of Hobbes' time is 10 minutes at 20 by 3. It will seem like, so that's how, say, I did the problem. So it's like back and forth between that. So I'll just take you so that it's not too confusing, right? Susie 2 hours, Susie and Kelvin 1 hour 40 minutes or 5 by 3 hours. Time becomes 5, 6. So speed has to be 6 by 5 or 1/5 more. 1/5 more of Susie's, right? Susie's speed increased by 1/5. 1/5 of Susie's. So Kelvin's speed is 1 by 5 means Kelvin's time will be 5 times or 10 hours because it's 5 times 2. Now Kelvin 10 hours, Kelvin and Hobbes 4 hours. Time becomes 4/10 or 2/5. Speed becomes 5 by 2 or 3 by 2 times more. That means Hobbes, who is joining him, has a speed of 3 by 2 times of Kelvin. Speed of 3 by 2 times Kelvin means time will be 2/3 of Kelvin. 2/3 of Kelvin is how much? 2/3 of 10 hours, 20 by 3. Yeah. So because I did it, this way, whatever, because I explained it without this thing, it will seem here. But for me, it's absolutely, straight away, going ahead. I know it seems like, yeah. So a bit slow. So we are consistently, well, the thing is, we didn't learn, we are not doing anything different from the core common sense that we are using, right? Throughout, we are using that same thing, right? So it is just exactly thinking, right? How did I get 5 by 3? What did I say? Suppose speed becomes 15 from 30, speed becomes 15. I do always new speed by old speed, that is, or new time by old time. So new time is how much? 5 by 3. Old time is how much? Alone is how much? 2 hours. So 5 by 3 divided by 2 is how much? 5 by 6. So my time is becoming 5 by 6. So speed has to become 6 by 5 times. That means 1/5 more. Where is this 1/5 more that I'm getting from? Because Kelvin has joined me. His speed is what? 1/5 of my speed. His speed is 1/5 means he'll take 5 times of my time. I take 2 hours, he takes 10 hours. So I get Kelvin's time. Now I do the same thing when Kelvin and Hobbes also. Kelvin alone is 10 hours. Hobbes 10. Along with Hobbes, he takes 4 hours. So along with Hobbes, his time is becoming 2/5. That means his speed has increased to 5 by 2 times his speed. So the increase in speed is how much? 3 by 2 times. And this increase has come from where? It's come from Hobbes joining him. So Hobbes' speed is 3 by 2 times his speed. If speed is 3 by 2 times, Hobbes' time has to be 2 by 3 his time, which is 2/3 of 10 and 20 by 3. Yeah. So if you want to do equations and everything, you can go ahead and do it. So you can do the calculation here. But I feel that from start to end, we are using the same concept to tie things together. Yeah. Now, we just have 2 more problems left, and I want you to be patient. Maybe just 10 minutes more to do the 2 problems, and then we'll discuss a few doubts. Right. So this is a very nice problem. Try this. So what's happening here? B moves by taking 3 steps forward and 1 step back, each step in 1 second. So what's happening? 1, 2, 3 steps forward, and 4th step is back. So every set of 4 seconds, He's taking how many steps? He's taking 2 steps. 1, 2, 3, back, 1, 2, 3, back. So B is moving this way, and when the escalator is stationary, he's reaching the top in 118 seconds, right? However, on a moving escalator, he takes 40 seconds to reach the top of the escalator. Find the speed of the escalator. Okay. So in the most traditional method, and say, that is there, what we know that he takes 2 steps in every 4 seconds. So in 118 seconds, how many steps does B take? 118 by 4. 4 divides 118 exactly 29 times. That means there are 29 sets of 4. And there is a 2 seconds extra. So in one set of 4, he takes 2 steps. So in 29 sets of 4, he takes 29 into 2, 58 steps. 58 steps, that is 116 seconds are over. In the remaining 2 seconds, he's taking how much? 1 step and 2 more steps. So totally the steps are 60. So now what does the problem say? In 40 seconds, when the escalator is moving, when the escalator is moving, B reaches the top in how much? 40 seconds. In 40 seconds, B will take 20 steps. In 4 seconds, B takes 2 steps. In 40 seconds, B takes 20 steps. Out of the total 60 steps, B is covering 20 steps. Who's covering the remaining 40 steps? The escalator is covering the remaining 40 steps. Escalator is covering the remaining 40 steps. 40 steps, and how much time is the escalator is also moving for? 40 seconds. 40 steps, 40 seconds. What's the speed? 1 step per second. Right? So this is the regular method of doing it. It also doesn't take too much time, but there is one more 118 by 4, 29. Why is it this 29.5? It's 116, 118 by 4, it's 29 into 2 plus 2, right? When I said 29, it divides this thing, right? So what exactly, happens? What is the question? The question says that he takes 1, 2, and 3 in every second. For the first 3 seconds, he's take one step forward, and in the 4th second, he takes 1 step back. So that means in a set of 4 seconds, he's taking 2 steps. Right? So, question once again, quickly. This is a question. So every set of 4 seconds, he's taking 2 steps forward. 4 seconds, 2 steps forward. That's so it's not like moving at, he's not moving at a uniform speed forward. He's coming backward, right? So that is how we calculated how many sets of 4 are there. There are 29 sets of 4 in 118. It does not divide perfectly. There is a remainder of 2 when you divide 118 by 4. So there are 29 sets of 4. One set of 4, he takes 2 steps. 29 sets of 4, he takes 29 into 58 steps. And the remaining 2 seconds, after 116 seconds, one set is over. In a fresh set, what happens? First second, 1 step, second second, another step. So another 2 more steps. That's how it is 60, right? So 40 seconds, B will take 20 steps when the escalator is also moving. Who takes the remaining 40 steps? So that's how it's 1 step per second. But you don't need to do all of this if you do ratios. So even if you say it did that whole calculation incorrectly of say 58 steps and all of that. So forget all of that. You let's look at it this way. Old time is 118 seconds. New time is 40 seconds. So time is becoming how much? Approximately 1/3. If time is becoming 1/3, speed has to become how many? 3 times. What is the current speed? 2 steps in 4 seconds or half a step per second. So new speed has to be 3 times. So 3 times is how much? 1.5. His speed is 0.5 only, half a step per second. Speed is becoming 1.5 times, means what is the speed of the escalator? 1 step per second. Think about this. There is no difference between 118 and 120. You're saying, sir, but this is all approximation. No, there is no difference between 118 seconds and 120 seconds, because in 118 seconds, he'll travel 60 steps. In 119th second, he'll travel how much? 61. In 120th second, he'll take 1 step back and he'll come back to 60. So whether it's 118 seconds or 120 seconds, it is the same 3 times that we are talking about. So if you see speed becomes 1/3, time is becoming 1/3. So speed becomes 3 times, half a step per second, 1.5, it becomes this thing, right? Now, a student did it even better, because I always like the best method. A student did it this way. He calculated the number of steps incorrectly as 59. He calculated 2 by 4, half a step per second into 118, 59 steps. But despite this mistake, what he did was beautiful. Time taken is 40 seconds. And he looked at this step. And then he took at each of, Now, if he's going at 40 seconds at 2 steps per second, how many steps will get covered? 80 steps. But how many steps are actually there? Only 60. So no answer beyond 1 is actually possible. It has to be only 1, because for 40 seconds, any answer more than 1 or any answer like to options 2, 3, and 4 will be covering more than 60 steps when they're actually only 60 steps. So Kaustubh, I think you got this when you did this. So I saw that, So all 3 are the other options not possible. This is the only answer possible, right? So again, ratio method is there. This is the method that the student did, right? Now we'll come to the last question, right? Now, when I said I was doing this question, okay, when I was doing this session, Amit sir, whom most of you will be familiar with, he takes most of the quant feedback. So Amit sir and I, one of the things about working with at IMS is that I have a good set of people to work with. So whenever they see a problem, they're very excited. They always share that problem. So I remember discussing this a long time back as soon as the problem was there, right? So both he shared this problem. So just go ahead and first maybe take a look at this problem. This is the problem in SimCat 2, right? So take a look at the problem. This is the last problem. So think through. Those who know this problem, anyway, that shouldn't be an issue. Okay. So 53% got the first part right, which is 60, but the second part 24 is incorrect, right? However, I'll discuss whatever I'm going to do next in terms of sessions. Right? Now, see, this is one of those problems where instinctively, when the moment Amit sir sent me the problem, when I said, sir, I'm doing this session. So he said, Tony, you should discuss this problem. It's a wonderful problem. So it's just like a bouncer and you instinctively hook. My instinctive, this thing was, okay, 12 minutes earlier than usual. That is the 12 kilometers, delay that is there, and 60 kilometers per hour. And, I said 60 without this thing. So in the actual problem, they didn't ask the second speed. They only asked the first speed. So it's one of those things, you hook, it goes for a 6, you take your 6 runs as, no matter how you get it, right? So I got 60, but then he asked the follow-up question, but what is the second speed? And because I did it by this, whatever quick method, I got a 24 this thing. Then I saw his solution. His solution is fairly good. So what he did was that he took the initial time as 9 a.m. and let them meet at 10 a.m. and he solved that problem, and it's a fairly decent solution. But then I thought students will be thinking, how did sir know that he can take the time as 10 a.m.? Right? And how, because you might think sir only, how do they come up with the stuff that in this problem I can take my meeting time whatever I want, right? So I felt that, is there a way to use ratios? And I was anyway making this PPT and I reached this far with ratios. I was like, let me think about this purely in terms of ratios and let me go ahead. So what do we know in this particular case? They travel at this, and they start at the same time and they meet at some point, which is Karnal. So let's call the first bus Delhi and the second bus Ambala, and they meet at Karnal, right? In case 1, what is happening? The Delhi bus was delayed by 30 minutes, and wherever is that meeting point, they met 12 kilometers short of Karnal. So normally they meet at Karnal, but because the Delhi bus was late, this bus came forward and they met 12 kilometers short of Karnal for Delhi. So before it did not reach Karnal, that bus had crossed Karnal and come here. Second time, what is happening? That bus got delayed by half an hour, and whatever time they usually meet at Karnal, obviously they cannot meet because the second bus got delayed, and this went further and they met 12 minutes later than their normal time. Okay. So now I want you to forget whatever you have done so far. I want you to forget your method, keep it aside for a moment, right? And let's think through in the same first principles or pure logical way that we're trying to look at this problem, right? So what happens? They meet, right? And the second bus, we are starting with the second scenario, right? So in the second scenario, what happens? The Ambala bus is late by half an hour, right? Now, ideally, and the yellow bus, suppose the yellow bus is the Delhi bus, and it is ideally at that exact meeting time, if it does not move ahead, it comes and stops at Karnal only, right? It comes and stops at Karnal. It is waiting for the Ambala bus. That means how much time will the Ambala bus now take? Because it started 30 minutes late. if the Delhi bus did not move from the meeting point and decides to stop there only, what will happen? It will have, because it started 30 minutes late, it will take another 30 minutes to reach that meeting point, right? But what is happening in this case? The Delhi bus is not stopping at the meeting point. Delhi bus is starting along with the, it's moving ahead. So what is happening? This 30-minute gap, that distance that is there, that the Ambala bus would have traveled alone, is now getting covered by whom? It's getting covered by both of these buses together, right? And this 30 minutes is getting covered in how much? 12 minutes, right? So now this is the scenario. If this had stopped at the usual meeting point, this bus, because it started half an hour late, it would have taken another half an hour, right? But this bus is not stopping here, so together. So essentially it's nothing but two buses moving together with each other. So when two buses move together, what happens? The speed gets joined, right? So if you add the speeds, the speed increases, the time is actually then has to decrease. Normally, how much time does the Ambala bus alone would have taken if both DNA had the same speed? Now, just think about this. If both DNA had the same speed, then how many minutes later would they have met? Then in the second scenario, the DNA had the same speed, and this is exactly at Karnal, and now they're starting. How many minutes later would they have met? Ambala bus needs how much? Speed doubles, so time halves, and 30 minutes would have been covered in 15. So ideally, Ambala bus takes 30 minutes, right? But I'm not waiting here, I'm going ahead. And if both our speeds is the same, that means that will take 30 minutes, I will take 30 minutes, speed is the same. That means together speed is doubling, time will be half, I will cover 15 minutes, right? I'm just explaining this slightly longer than required so that the conceptual part is there, right? But how much time are they actually taking? Along with D, A's time comes down from to 12 from 30. 15 is half, 12 is less than half, right? 12 is less than half. That means the joint speed is more than double. Joint speed is more than double means D is faster than A. So without doing anything, you know one thing, that D is faster than A because time is less than half and speed is more. This is just extra bit of information, just conceptually to understand. We are traveling towards each other, but we're starting from a point, speeds are equal means speed is double, time is half, right? If I'm taking less than half the time, that means speed is more than double, then one of us is faster than double. Now we go to the problem. No, we know it's fairly simple here. What's happening along with D, that 30 minutes is coming down to 12. So speed has become how much? 5 by 2, because this has become how much? Time has become 2 by 5. Its time becomes 12 by 32 by 5. Speed has become 5 by 2. Speed has become 5 by 2 means 3 by 2 is extra. So this extra speed is nothing but D speed. D speed is 3 by 2 times A speed. D speed is 3 by 2 times A speed is nothing but the speeds are in the ratio 3:2. If speeds are in the ratio 3:2, what happens? In the first situation, this bus would have come and waited, and this would have taken 30 minutes if it's going there. But that is not happening. At the 30 minutes would have gone there if the second bus had waited there at Karnal. Because in the first situation, this bus is 30 minutes late. But instead of waiting, they're traveling towards each other. And this is traveling 12 kilometers. Now the speeds of the yellow bus and the white bus are in the ratio 3:2. That means the distance traveled in the same time will also be in the ratio 3:2. So if this is traveling 12 kilometers, this will travel 18 kilometers. Yeah. The 3:2, same ratio. The whole thing is working, right? Now, the beauty of this problem is if you do it in this ratios method, the entire problem, any question they ask, you can answer. Because think about this. This is 12 kilometers, that's what they gave. And they gave this time is taking 12 minutes. From this 12 minutes, we found out that this is taking 18 kilometers. So just to go back, how did we solve this problem? This time, first case is 12 kilometers, and this is 12 minutes late. So, that 12 minutes later, that is where they are meeting, right? 12 minutes later, so normally if A alone was traveling, it should have been 30 minutes. Speed became 2 by 3, time became 2 by 5, speed became 5 by 2, 3:2 speed. So we got this as 18. Now look at the whole problem. This distance is how much? 30 kilometers. So this 30 kilometers, how much time would A have taken to finish this? In D would have taken 18 plus 12 is 30 kilometers in 30 minutes. So the speed is how much? 30 kilometers in 30 minutes is nothing but 60 kilometers per hour. Now, if that is 60, what is the other speed? That is 40. You will also get that these two, they will also be in the ratio 3:2, because whenever the speeds are in 3:2 ratio and they're traveling for the same time, everything will be in that same ratio of 3:2, right? Even when they meet at the first meeting point, the total distance covered by each of them will be 3:2. This time also will be 18 minutes if you see, because the speeds are in the ratio 3:2. Right? Totally, this entire problem will completely be about this ratio of 3:2. Right? Is the problem clear, or do you want me to explain any part once more? Yeah. One slide back. Okay. What did we do? We'll just go back. We know that D should have taken 30 minutes to reach the midpoint, wherever they usually meet, right? But they met only 12 minutes later. I became 30 minutes late, but my meeting time got delayed by only 12 minutes. Why did my meeting time get delayed by 12 minutes? Because my other bus didn't wait there, it came towards me, right? So when two buses are traveling together, the speed gets joined. So time that I alone would have taken 30 minutes to finish, because we are traveling together, it finished in how much? 12 minutes. So time became 12 by 30 is how much? 6 2s are, 6 5s are, 2 by 5. If time became 2 by 5, that means speed has to become 5 by 2. That means my speed increased by 3 by 2 times. And that extra speed is coming from where? Because of the bus traveling from the opposite direction, which is nothing but D speed. So D speed is 3 by 2 times A speed, or speeds are in the ratio 3:2. Now we go back to the first case. In the first case, what is happening? Ideally, this, the first bus is 30 minutes away, right? But the first bus is 30 minutes away because it started 30 minutes late. And it would have taken this 30 minutes to finish. But the second bus did not stop at the meeting point. It also traveled and they met somewhere. And in that traveling, it took 12 kilometers. Now, because the speeds are in the ratio 3:2 and they're starting at the same time, whenever say this reached the meeting point, this has reached some place. This bus is 30 minutes away. Now they meet, and this bus has moved by how much? 12 kilometers. They meet farther than the meeting point at 12 kilometers. Because they're traveling for the same time, speeds are in the ratio 3:2. This is a faster bus. The distance will also be in the ratio 3:2. Right? Now we go back to the problem. So we know that the first bus, right? It is when it is this bus traveled 12, the other bus traveled 18. Right? This total distance from the meeting point, it was away by 30 kilometers. And it was away by 30 kilometers, and it would have covered that. The delay is how much? 30 minutes. 30 kilometers in 30 minutes means how much? 30 by 30 into 60, that is 60 kilometers per hour. So the first bus is traveling at 60 kilometers per hour. The speed is in the ratio 3:2. So other buses in the ratio in 40 kilometers per hour. Right? So we can calculate both of these also. How can we calculate both of these? Both are traveling at 12 minutes. So 12 minutes, this one is traveling for 60 kilometers per hour. 1/5 of 60 is how much? 12 kilometers. This is traveling at 40 kilometers per hour. 12 is 1/5 of an hour. 1/5 of 40 is how much? 8 kilometers. So this also will be 20. Right? So this total duration, how much will A take? 18 kilometers at 60 kilometers per hour. This will take 18 minutes. 12 at 40, that will also be 18 minutes. So this will also be a 3:2 ratio. This total distance, original meeting point also, this distance will be 3, this distance will be 2, because that ratio is 3:2. Right? So this whole problem, if they ask, so this is one problem where in this one question, they could have asked 5 different questions. What is the speed of D? What is the speed of A? How much distance did D travel to meet A the first time around? How much distance did D travel to meet A the second time around? They could have asked an entire range of questions, and you could have answered every single question using this method, because we are sticking to that very core point of ratios and how we are doing. So why 60? 60 is nothing but, say when we are saying second time, what you call, this problem will take a bit of this thing, bit of explanation to do. So, which is why, D speed of 60 is simple, because at this point where say D was delayed, right? D was delayed and this person is the meeting point. This person, the second bus traveled 12 kilometers towards D to meet. And D in this point at same time would have traveled 18 kilometers, because speeds are in the ratio 3:2. Now, if the second bus did not move, this whole distance would have been covered by D only. And how much time would D have taken? 30 minutes, because that's a 30-minute delay that is there. So D would have covered this whole 30 kilometers normally if there was no delay in that 30 minutes time. This gap of 30 kilometers has come because of that 30-minute delay. So 30 kilometers in 30 minutes. So what is the speed? 30 kilometers in 30 minutes means 30 by 30 into 60. That's nothing but 1 kilometer per minute. In 60 minutes, 60 kilometers per hour. So which is why this is 60 kilometers per hour. And we know that speed of bus 1 and bus 2 are 3:2. So that because 60 means this becomes 40, right? This is 3:2 ratio, right? So it will take some, one more, round for you to look at this. And different colors used. I used different colors used. Why did I use different colors? Yellow is when the first bus got late, and blue is when the second bus got late, right? So there are two situations. Yellow is when the first bus got late. Blue is when the second bus got late. That initial red and green are their initial part which they're using. Just going back to the question. Yeah, we'll go back to the question once more. So that there is a small typo here. This is not 12 minutes earlier. That's 12 minutes later than usual. Sorry, my bad. That is 12 minutes later than usual. So this 30-minute delay got converted into a 12-minute delay. 30-minute delay got converted into a 12-minute delay. So the time taken, what should have taken 30 minutes, got covered in 12 minutes because the second bus started here. So time became how much? 12 by 30 or 2 by 5, which is why the speed should have become 5 by 2. In the first case, if there was no 30-minute delay, this bus only would have gone all the way to Karnal, right? And it would have taken that 30-minute time to this thing, right, to meet. But it got delayed by 30 minutes. Ideally, if it got delayed by 30 minutes, it should also meet that bus 30 minutes later. But because that bus is also moving along with it, they finished the task together in 12 minutes. So time became 2 by 5, speed became 5 by 2, extra speed is 3 by 2. That 3 by 2 speed is nothing but extra speed is what? The other bus moving in the opposite direction. So if D speed is 3 by 2 times this 3 by 2 extra is nothing but D speed, that 3 by 2 times is A speed. That's why the speeds are in the ratio 3:2. We'll go ahead. Maybe it'll take some understanding for you to think through this later. So do that. So, but what we did was a very simple thing, that two buses meeting together in opposite directions, right? It's nothing but that speed, that kind of speed gets added and time gets this thing. So that is exactly what we did. We do that opposite direction is nothing but two people working together, right? Working together with Kelvin, my time became 5 by 3, right? I took 5 by 3 hours, so time became 5 by 6. Similarly, traveling in opposite directions, because traveling in opposite direction means along with that other person's speed, my time became 2 by 5. Right? So it will take a bit of understanding. You can do that. So one of the things, big things is that you should stop starting a time speed distance problem with this let the distance be D, right? Let the distance be D is the worst way to start time speed distance problem, right? Because that means that what you're trying to do is the moment you see a problem, you're trying to put algebra onto it and trying to form an equation. And the reason to use an equation, kahin na kahin, something will get cut and I will get the answer, right? So this, I'm not saying it should not, but that should not be your first response to a time speed distance problem. Cannot be that, right? Do not be in a hurry to frame an equation. You might be choosing the longest way out. We always want to somehow take a time speed distance and fit that and force fit that into a S into T is equal to D situation. And then we hope that the answer will come somehow. We are not doing any thinking. Take whatever is the problem and try to fit it into S into T is this thing. Don't be in a hurry to do that. The tougher the problem, the more likely it is that you will not be able to frame an equation. This problem also, trying to frame an entire equation will be tricky. Whenever problems become 4 lines, 5 lines, 6 lines, 7 lines, you will see, I've seen always that the solution is not an equation solution. The solution will always be a logical solution, right? What is the reason for that? If you look at as time speed distance as a very simple concept, speed into time is equal to distance, or distance by speed is equal to time. Exactly like probability is a very simple concept. What is the probability of something happening? Number of ways in which favorable occurrence can happen divided by total number of occurrences. Which is why in both these areas, the problems get most creative. Problems become super creative. in both of these areas, because the concept is very simple. Which is why you see they will come up with all sorts of problems. The thief is running after the police station, then the cop runs after the thief, then the cop's dog runs after the thief. Two things are coming in opposite direction, something gets stuck, goes back. Why does all of this happen? Because the core concept is very simple. I can weave any story out of it, right? So trying to set up an S into D, TD always is maybe not the best idea to look at it, right? Out of all methods, the ones involving LCM and man days and ratios are the most effective. LCM is, let's take the total work as a LCM of number of days taken. That is fairly effective. And also looking at man days, we did that 10 men taking 40 days means the number of man days of work is 40. So these are most effective. I feel, it's a personal opinion, you might choose to disagree, I feel that that's much better than efficiency and percentage calculation. If you take LCM and total work is so much as the LCM, that and man days, and I personally, my go-to method is ratios, because I can do all of this calculation fast and I don't need to then sit and add fractions and stuff, right? So the rest of the methods to solve rate problems, fractional work, percentage work, nothing against those methods. But I feel they're clumsy. LCM, man days, ratios, definitely a much better method to go ahead. In this entire, for the last, say, close to 2 hours that we're talking, did we do math or did we do reasoning? We were constantly doing verbal reasoning only almost, right? My speed is becoming double, or, my capacity is becoming 3 times. So my speed becomes one, this thing. So where did we do math throughout this whole setup? I don't think we did math. I don't think it's a situation as math, right? But what we did was pure reasoning. Speed becoming triple, this becoming 1/3, this. So we are in that space. So I feel that for me, that gives me a great deal of width because I'm in that reasoning space. And arithmetic is primarily English, right? A lot of that problem is a lot of English only in terms of what is happening. So I feel that if you can move from remembering 50 things, 50 methods of doing and it being math, right, to you moving to pure reasoning. So how do I put this? Because some of you said, no, sir, I'm very comfortable with fractions method and I am very, very, can we, use my fraction? When do we use this? When do we use it? Now, the advantage of the ratio method is, say, just to give you a gym example, there are some exercises if you go to a gym or when you're doing any sort of weight training. So if you're doing something like an overhead press or a barbell, this thing. So these exercises don't just help you exercise that one body part, but the whole body gets exercised, right? When you're doing it, if you're standing and you have weights on your shoulders and you're doing a weight barbell squat, your legs, your chest, your shoulders, everything gets a full body workout. But if you're only sitting on a machine and doing one isolated exercise, you're doing only that one thing. So some of these methods, the method of ratios, as I said, to use it, it is not something new. It is not like a concept. It's like, if I'm saying that, speed and time are inversely proportional, you cannot tell me, sir, this is a new concept. This is a new, this thing. It isn't the oldest concept in the book. And we are just applying that concept in different context. It is rate only. Everything is a rate problem, right? So don't be afraid. Right? Don't be afraid to try this. You're just adding something more to your arsenal, right? In terms of what you're doing. Right? This is the main thing. If you think like a laborer, you will want no offense to laborers, right? In the sense that if you don't like this reasoning space and wanting to do this thing at that space and you want to do the, what you call hard work wala method, the fact is that will take you only that far. This would also mean, so don't be scared to say that, I know this, now I'm going to sit and, do this only this way. Don't be scared, that these stunts are performed by professionals. So this is not one of those things, those bike stunts, these stunts are performed by professionals. You should not try this at home. You must try this at home. You should definitely try this at home. For some of you, maybe you're going through this whole webinar, maybe one entire day, even if you take, it is fine. Even if you take an entire day, but understand this thoroughly, you will gain more than by sitting and practicing an endless number of problems of the same type in the same method. Right? So I feel that do not treat this as this thing, you treat this as another, way of solving, right? It's a skill And as I said, I was not born with this method or whatever. I saw somebody do it and I felt that, okay, this is really quick, and I was not scared to try it. What is coming up in terms of the future sessions? That's where so the upcoming posts on CatWriter, that's the blog that I run, thecatwriter.com, right? So those of you who don't know it, so that's the blog. So I've already done the entire series on quant. I've done a series on VRC. So when I said an entire series in here, so a few more things are there in VRC. I'll do DILR percentiles and how to improve DILR percentiles. There are 3 parts on that. I'm going to do one on mastering, reading comprehension. It's maybe something is in addition to that, but and for all, so that is upcoming on the blog. For all the previous webinars that are there, the 6 previous webinars, including weighted averages, you'll find that, as I said, on my blog, The CatWriter, and also on the YouTube page. What more is coming up in terms of IMS events? We'll be doing 12 masterclasses for all the students. So in these 12 masterclasses, I'll be doing 3 masterclasses for verbal. So I'll be doing 2 for RC and 1 for verbal ability. So that is definitely there. Apart from that, in August, September, and October, we're coming up with a series which is called Last Mile to CAT, which will have very, very specific section-wise test-taking strategy. How should I select the questions and what sequence should I attempt? Right? So for each section, we'll take last year's CAT paper and demonstrate an entire section-wise solving strategy. We will also tell you about how to do the B-School selection, how to plan your ADMAT preparation, test-taking mindset. So essentially everything that is required we'll be covering, and we'll be also providing recorded videos. Either I'll do it or Amit sir will do it, or after last say few years CAT papers. Especially maybe not just solved for the sake of solving it, but solved well. That is where the fun is, right? So this is what is coming up both on the blog as well as master classes. Some of maybe my master classes I'll make it maybe available for the rest of the readers of the blog who are non-IMS students as well. Otherwise, Last Mile to CAT event and the master classes are specifically for IMS students, and on my blog you'll have the other stuff. I hope the session was useful. It was heavier than usual, but I'm sure that if you go through it, there will be enough and more value. Yeah. So I think we have different questions that are coming in. So with respect to quant, the section as such, how to select questions specifically, so the big thing is how to select questions, how to improve your score. I've done 3 very, very detailed posts on that, on how to improve your score, QA score, part 1, part 2, and part 3. On the blog, catwriter.com, all you need to do is go there, go to QuantStrat, and you click there, you will find all the ones on improving your quant score, right? The rest, when I do that there will also be a repetition of that using the latest CAT paper. When I do, I will be doing that in the Last Mile to CAT session, right? How to improve RC, I've put about, say, 3 to 4 posts, Biraj, on that on the blog, so you can go ahead and do. So there, is it a good idea to join Toastmasters Club now or after all the exams? Shardul, if you have time to do the Toastmasters one, if you have a whole day at your disposal and you can do it, you can get that, right? Sarvesh says that I'm not sure always whenever to try out ratios. See, the big thing to try out ratios is when the distance is the same. So whenever the distance is the same, you can completely go ahead with the same ratios. If you see in all the problems, we're talking about the same piece of work being done by Calvin and Susie. We are talking about that same distance that both the buses are traveling in the opposite direction. So whenever the distance is the same, you absolutely have to go for ratios, right? When then or when the overall job is the same, when the job is not changing, right? So that. So would it possible, Trayambak, you're saying this, would it be possible to get this shift in the way we approach a problem now 3 months from CAT? Trayambak, I've told you from my personal experience that I joined the prep in this thing in June, and I think it was around, say, September or something that I saw this is many years ago. The test used to be conducted in the first week of December, then, right? It is not necessarily about completely rewire. We might think that it's like a big rewiring of the system, but it's essentially just an approach that is used in specific things. You don't lose anything by trying it out, right? Doesn't do anything much. Yeah. So it's not something that you should be scared of, right? Manish says, can you give more questions along with solution practice by ratio method on your blog? See, the thing is that whether I do 5 questions or whether I do, say, 50 questions, the 51st question has to be done by you, right? So whenever, that is maybe the key thing to remember, right? The core concept does not change, right? So if you look at the basic move and this one, I covered in this all the core scenarios where you can use this. Now, after this, the problem will be, new. Right? So those of you who like the blog, like the session survey, I think, yeah, good to hear that, like the work that I do. Right? Means Matthew, any advice for working professionals preparing for CAT or planning to quit and dedicate, completely for, CAT prep? I think I'll put some things on the plan, that shouldn't be, yeah. So in terms of any advice, start from your weakest area and become an all-rounder who can solve the basic level questions from every single area. That is maybe the first thing that would be, required. Yeah. Scores keep fluctuating in QA. Parash, you have to go and see if you're actually doing the ABC approach, which is selecting the right questions. Parash, so you have to go check my blog, thecatwriter.com, and look at those 4 posts that I've done in terms of, are you doing those things? So I've done one on accuracy, I've done one on selection, I've done one on speed. So I've covered each of these 3 things: accuracy, selection, and speed. You should look at those 3. Okay. Vidur says, score about 14 quant, majority are arithmetic, but scores dive down on the question geometry. I want to depend, like, how do I improve? Vidur, geometry, if you're looking at geometry, the reason geometry can be scary for most people is if you're thinking geometry as a set of formulas. It's like the moment you see a geometry problem, if you're thinking what formula, you're done for, right? So I would say geometry, the only difference is that geometry has quite a few formulas, that is sure, but it's just about a few properties. And if you start thinking about even geometry from a logical reasoning angle, right, it is not, it's something that you can cover. So if you hang around for time, I know I can make geometry fun also. So geometry is my favorite area as well. So maybe, I can, I don't want to bore other people with a cute geometry concept, right now. But, geometry, obviously, it's just about maybe changing that thing in your head that, as I said in my first session of, say, learning to learn math, if you think of it as a game with some rules, chess has this rules, Ludo has this rules, geometry has this rules, but knowing the rules does not mean that you can play the game. So people confuse geometry like, knowing the rules of the game. The rules is just one thing. Finally using, that horse will move this way, bishop will move that way, queen will move that way. Is that chess, or how do you play chess? You play chess. So play geometry and you'll get it. If you think geometry is the rules, you'll get caught there. Yeah. Arithmetic section, have not touched other sections. Should I give mocks regularly score? So Anmol, I would say that if you finished arithmetic, do all the other sections, at least say don't give a mock, at least if you can, say quickly, at least reach the solve easy questions in all 5 areas. Right? Easy questions. So don't sit and say, I want to finish the entire material of quant across entire this thing, all levels. Just learn the concepts and solve the easy questions. At least you know that if there's a 3-mark sitter from geometry on circles, you can take those 3 marks. So we'll wrap up. I hope the session was useful. I'll see you later on the next session. Yeah. Thanks a lot, guys. Hope this was useful. Bye-bye.